Hey guys, today we're going to discuss this problem. So let's begin with the example here. So here is the input. We are going to have 6 test cases in the input, and for each case, we are going to have the length, and the following array uh, is is just a array of numbers. And in the problem, we are going to define a 3-block palindrome as a sequence consisting of at most 2 distinct elements. So the 3-block palindrome is like this. So the left part has X A's, and the right part has X A's, right? The length has to be equal, and the number has to be the same, right? And in the middle, there are Y B's. So the X and the Y can be equal to 0, right? That means we can just have one part and remove these other 2 parts. And for example, the empty string is a 3-block palindrome because uh, all of these 3 parts has length of 0, right? And for this guy, also a 3-block palindrome because here x equals to 0, y equals to 1, and b equals to 2, right? And for this guy, also a 3-block palindrome, x equals to 1, a equals to 1, y equals to 0, right? So on and so forth. And these guys are not 3-block palindrome because we have 3 different numbers here, and this is not in the form like this, so they are not a 3-block palindrome. And we are going to find the maximum length of subsequence of A that is a 3-block palindrome. That means we are going to remove some numbers from this array and make the rest of the array 3-block palindrome. And we can not change the orders of these numbers, right? So for example, what is the longest 3-block palindrome we can have for this array? So let's see, we can remove this guy, right? And the result is 1, 1, 2, 2, 2, 1, 1 is 3-block palindrome, right? So it has 7 numbers, so we output 7. So how do we solve this problem? So we are going to use brute force search, right? Because in the problem we can know that the maximal value of A can be up to 200. That is not a really big number, right? Just 200. So, and for each of the 3-block palindrome, only 2 numbers are selected, right? So we can just use 2 for loops. The first for loop iterates all of those numbers once, right? And use it as A here. And for the second loop, we iterate all of those numbers as B. So we have A and B here, right? So A is I and B is J. So we are going to use I and J to create the longest 3-block palindrome from the given string, right? How do we do that? So we can have 2 pointers right? And the first pointer pointed to the start of the array, and the second pointer pointed to the end of the array. And we move these two pointers. So in a way that um, in before we move it, the start of the uh, these two pointers is stands for the end of the first part and the start of the second part, right? So if we put the if I equals 1 here and j equals to 2 here, the initial position of the first pointer is pointed to here, right? And the second pointer is pointed to here. And in this case, we don't have, we can construct a 3-block palindrome like this, 2, 2, 2, right? Because if because the end of the first part is here, so for the first part we don't really have anything. And because the start of the third part is here, so we don't really have anything here as well. So the palindrome we have is like this, right? Only the middle part, 3 twos. And then we are going to move one step for both of the pointers, right? Let's say we move the first pointer here and move the second pointer here. So in this case, we can construct a 3-block palindrome like this, right? Because the end of the first part is here, so we can get a 1 from this part, right? So we can add a 1 to the final 3-block palindrome. And also for this part, we can add another 1 here. So this is the end result. And we can see that this is longer than previous 3 twos. So we can use this as the end result and move on. So we move the two pointers one step further. So one pointed to here, and the other pointed to here. So for the first part, we can have one more one, and for the third part, we also have one more one. And for the middle part, we uh, don't actually need to change, right? And so the result is like this, right? So let's do it again. Uh, Move on. So sorry about that. So now the first pointer pointed to here and the second pointed to here. So in this case, we don't have more ones added into the final 3-block palindrome, right? But we lost 2 twos because we moved the A, the last A here, and the first A here. So we lost 2 twos, right? So in this case, we remove 2 twos. So this is even smaller than our best cases. So we don't use it as a final result. So I guess that's it. We just use two strategies here. One is brute force to iterate all those possibilities of A and B combinations. And the second is to use two pointers so that we can get the longest three-block palindrome for each of the AB combinations, right? So let's look at the code here. So first, we are going to read the number of the test cases and read n. And this is where we save the best result. And this is where we read all those numbers. And for each number, we are going to record its position, right? The position array here is that, let's say we have a position array 1, which saves all of the positions of 1, right? In this case, it's 1, 2, 3, 4, 5, 6, 7, 8, right? The 1 appear in 4 different positions, 1, 2, 7, and 8, right? And then we are going to update the answer here with the number of occurrences of each number, right? Because let's say if 1 appears 4 times, so in the final answer, we can at least get a 3-block palindrome with all these numbers, right? So we update the answer here. And then we're going to do the brute force search. So iterate all those AB combinations. And then if I equals to j, we continue. And if one of them is empty, we continue, right? And this guy is the best 3-block palindrome we can find for each AB combinations. And here is 4 pointers. The I pointer is a pointer point to the A, right? The I0 is pointed to the first occurrence of the A, and the I1 pointer is pointed to the last occurrence of A. And also for B, for the J0 is the first position of B, and the J1 is last position of B, right? And here is the counter. So this is the current counter of I. So um, let's say we have 3 block palindrome like this. Then the I equals to 1 and the j equals to 2. Then I count here is 4, right? We have 4i. And the j here is 3. We have 3j, right? And we are going to move the pointers from 2 pointers until they meet up, right? And the initial state of I count is 2, right? We start from the first occurrence of A and the last occurrence of A. And then we are going to remove all those J's occurrence if that occurrence is before the this pointer or after this pointer, right? And then we can just use the current length of the 3-block palindrome to update our best answer. If it is bigger than our best answer, then we use it as our best answer, right? And then we move those pointers. And we are going to update the final answer with the best answer we can get for this particular AB combination, right? So in the end, we are going to output the final answer here, right? So I guess that's it. Thank you for watching. See you next time.